Hello, my BC peeps. This is lesson number 44, improper integrals. So what is an improper integral? Well, I have an example before you, and here's why it's improper. We have this infinity here. Infinity is not a number. So how do you integrate from 1 to infinity when infinity is not a number? And we can't apply the fundamental theorem of calculus because infinity, again, is not a number. So here's what we do. Let me draw a picture of what this function kind of looks like. Here's the right half. It looks something like that. So when we're integrating from 1 to infinity, from 1 to infinity would be this area if we kept going and going and going, which is kind of strange because how do you find the area if it goes forever, infinity? So we actually stop. We are only going to go from 1 and stop at A. And so here's what we're going to do. We take the limit. No, I'm not even going to do the limit yet. I'm a liar. My pants are on fire. So what I'm going to do is I'm going to integrate from 1 to A of 1 over x squared dx. Well, I know 1 over x squared is going to be x to the negative 2 power. And I know you add 1 to the exponent and divide by that from 1 to A. And after we plug everything in, we get negative 1 over A minus negative 1 over 1. Bam. Okay. So what do we have? Negative 1 over A plus 1. Well, that, as I said earlier, is going to be the green region. Then we say, hey, what happens if we take A and let it slide out to the right? Well, how do you do that? Well, with a limit. We take the limit as A approaches infinity. Again, A is going to go to the right forever of our answer that we had. Now, as you can see here, 1 divided by infinity is going to approach 0. So that's going to be 0. Answer is 1. So the area under that curve, if you go forever to the right, is 1. So when you have an improper integral, when it actually has a finite value, we call this convergent or converges to 1. Because if you add forever and ever and ever and ever, it keeps on adding, and that sum approaches 1. So it converges to 1. So in summary, here's what's going on. If you have an integral from 1 to infinity, or your infinity could be on the bottom, then you rewrite it. Instead of going to infinity, you stop at A, and you take the limit as A goes to infinity. And all the work we just did is what we did above, and we saw they came out to be 1. So that's how you would do that. So that's the first case of an improper integral, is when one or both of your limits of your integrand are infinity. Okay? The next one is this example, and that's when you have a vertical asymptote within your limits of your integration. So between 0 and 3, there's a vertical asymptote at 2. So if we were to graph that, what we see when x is 2, there's going to be a vertical asymptote. This graph will look like this if we were to graph it. This is a rough sketch. So the concept of the integral, we would be finding the net area of that, and then the net area of that, and take the top, subtract the bottom. And, whoops, I was supposed to stop at 3. I lied again. Yeah, there we go. I'm stopping at 3. But The problem lies is these infinities here. It's kind of an odd thing. So what we actually have to do is break it up into two integrals. We have to go from 0 to 2 first, and then 2 to 3, and we have to do some special stuff. So here is what you do. Like I said, you can go from 0 to 2, but I'm going to call 0 to a. And then I'm going to go from b to 3. And why am I doing that? Let me show you. So this is a no-no. It's improper there. So I'm going to approach 2 from the left. So in this region, I'm approaching 2 from the left. So I want to take the limit as a approaches 2 from the left. And then on the right side region here, this is a no-no. So I'm going to approach 2 from the right for this region. So here, I'll take the limit as b approaches 2 from the right. Then I do some fancy schmancy calculus. Now, technically, this is a u sub. You make x minus 2u. But after you do your u sub, you should get ln x minus 2 from 0 to a. And you should get the same thing here, ln x minus 2 from b to 3. We do our fundamental theorem of calculus. And we get the limit as a approaches 2 from the left of, I plug in a, and then I plug in 0, then I plug in 3, and then I plug in b, excuse me. Now all the magic happens. So I'm plugging in numbers to the left of 2 here. So 1.9999, we get a negative 0.00001, which absolute value makes it positive 0.0001. But if you know what the ln looks like, as you get close to 0 with positive numbers, that is going to go to negative infinity. This is not going to change. And then ln of 1 is 0. We ignore that. Now, we plug in numbers to the right of 2. So 2.0001 minus 2, that's a positive 0.0001. ln of numbers that are positive really close, again, like I said earlier, that's going to be negative infinity. Okay, I'm losing track. Whoops. Whoopsie daisies. I have a minus, but that's going to be minus infinity. Oh my. Actually, I am not sure. I'm a bit confused. Because that's going to be plus infinity. Are those infinities the same? Because not all are the same. I actually think they're the same. I think the answer is actually negative ln 2. And I don't even know that's right. I'm going to have to check. I'm going to go to Wolfram Alpha and check this out on the computer. But man, I'm thinking that that's the answer. Now, if this answer were infinity, then I would have an answer that diverges because it doesn't approach a number. But this actually, I believe, converges to negative ln of 2. So remember, you write diverges if the integral goes to infinity. All right, one last comment real quickly. Let me throw this out at you. So suppose we had from negative infinity to infinity of some function like this. How would you do that? There are a couple weird things going on. You know what? I don't even want to do this one because this is going to throw you off. So let me change the function. I don't want to have a vertical asymptote. Let me do this. Let my brain work here. Let's do, yeah. Let me erase this. We're not going to work this out. I might make an integral that's unbearably yucky. Square, yeah. Oh, sorry. Let's do 1 plus x squared. Do I want that? Okay. This is just for example. Don't worry about the integral and what it comes out to be. But you have two infinities. So you need to break this up into two integrals. So you go from negative infinity to any number you choose between. I'm just going to choose 0 because 0 is a nice number. And then we go from 0 to infinity. I just break into two parts wherever I want to. These numbers here could be a billion, could be 1, could be 5. It doesn't matter. You get to choose whatever you wish. And we get that. All right, so I just realized what I should have done for my function. Oh, well, no big deal. So now for this one, you have to take the limit as a approaches negative infinity from a to 0. And this, you have to take the limit as b approaches infinity from 0 to b. So just to let you know, you would break this up into two separate integrals when you have both limits of integration are infinities. So that's the end of the lesson. Hopefully that helps you do your homework. And if you have any questions, I can answer those on Tuesday in class. All right. I will see you guys later. Bye.